Up next, we have Maryam Masoomi, a doctoral student in civil engineering. Her presentation is titled Soil-Based Mixtures for 3D Printing in Construction. Let's welcome Maryam to the stage.
In Netherlands was built using 3D printing technology. This structure illustrates the potential of 3D printing technology in generating complex structures. My research focuses on developing soil-based mixture for 3D printing. But I'm not printing bridges. I'm printing small blocks like this. And the ultimate goal is to developing a mixture for large-scale 3D printing. A 3D printable mixture should be able to flow under pressure while it's retaining its shape and its property. And it should have the ability to support the weight of upcoming layers without deformation. But why do we need 3D printing with soil? Construction industry is one of the polluting industry in the world. It's responsible for 38% of global CO2 emission. 3D printing with soil can significantly reduce this number. Soil is an old building material. It has low carbon impact, and it offers excellent insulation property. It's offering energy efficiency. It is readily available, it's abundant, and cost efficient, which makes it a sustainable material. But earthworks are labor-intensive and relatively slow. 3D printing, by automating manual tasks, can reduce the need for large number of workforce. And also, it can make it faster by depositing the material into the desired shape without formwork, and it can operate continuously. So, however, there is a significant obstacle stand on the way of using soil for large-scale 3D printing. Soil composition varies from region to region. Not all the soil are good to be used for 3D printing and construction. To address this, in my research, I am examining different kinds of soil, from synthesized soil to natural soil, to find the right composition of the soil that can be used in 3D printing. This will help us, first, find the amount of water by correlating soil property to the amount of water that should be added to the soil to make it flowable, extrudable, and buildable. Second, it will help us to optimize the amount of cement and binder that should be added to the soil to make it strong and durable. Some soils, like clay, have binding capacity. Their presence inside the soil will reduce the need of adding a lot of binder to the soil, and this will make the final product sustainable. So I'm trying to transform the soil into the high-performance building material. Gaia is an example of a 3D printed house in Italy. For soil, they used silty clay, and for stabilization, they used a biocomposite of lime and rice husk, both widely available in Italy. The outcome of my research will enable us to have more houses like Gaia in other parts of the world. I hope I could provide you a perspective on how 3D printing with soil can make construction faster, sustainable, and cost-efficient. However, we still need to develop robust codes and standards to evaluate the mechanical properties of these structures. If we can generate these complex structures, imagine what else we can do. One block at a time. Thank you.